But yes, we did see it, beginning of the year, but not into variables. So working on this warm up.
Yeah, I'm about to get that.
It's supposed to be done graphically.
Yeah.
Yes.
I totally forgot about the quiz somehow. Is it okay if I don't take it today? Because I'm not
Yeah.
quite feeling up to
It
it.
would be strange for you to take it.
Yeah, thank you.
Thank you.
Just wanted to-
Want to use that time just to catch up or
Okay, yeah, should I just watch the videos probably?
yeah, if you're gonna do that, then you're gonna want to go.
Yeah.
Okay. Sure.
What do you have to do like share slides and stuff like that? Yeah.
Yes.
Well,
Like, you know,
Here we go.
for a while. Okay.
Okay, so I was
Like, I don't think it's technically like. Okay, tests. So. Grade around the corner. I want to like get
This is
them
just like
as
a.
many as I can.
There should be
Before I
like
forget it.
this type out. It's only bracket.
No.
So you have. It's a line.
Okay, are we ready? Well, ready or not, let's do this. I noticed in my last class that kids have an addiction to slope intercept form,
It's awesome.
which is awesome. It is awesome. Do we agree the slope intercept form is awesome?
Yes.
Okay. But the problem is that you might be addicted. Any equation, you try to put in slope intercept, even if it's not a linear. That's an issue. Get help. Just, no, I'm here to give you other options. So my recommendation, instead of putting that first one into slope intercept form, yes, Baron.
Or are these choices?
Options.
Options.
Options. But I would like you to listen and just consider. Consider it, and it's completely up to you. There's nothing wrong with slope intercept form, but if you're addicted to it, there is help. So for the first line, instead of solving for y, what I'm gonna do is just get the x-intercept. And I get that by setting y equal to 0. So I cover that second term in my head, and I see automatically that x equals 4. Do you see that x equals 4? For the x-intercept. Like I'm imagining an equation in my head. The top one, the top one. Top one. Yes? For the other one, I just need one more point to draw a line, so maybe I'll find the slope. No, I'm going to find the y-intercept by making x equal to 0. And do you see -6? Okay, cool, -6. And now the line, since it's just less than 12, it's not going to be a solid line. It's going to be dotted or dashed. I'm going to move this 4 over just because I'm a little bit uncomfortable with the scale being not to scale. But this is good. It doesn't have to be, but hey, let's make it somewhat accurate. And the fact that this is less than 12 means we're going to take this dashed line, that's going to be the boundary. And one of these sides will have to be shaded. Did you already do this? How do you decide which one is shaded? If it's in slope intercept form, if it's y is greater than, you're going to shade above. If it's y is less than, you're going to shade below. I messed that up. I said we don't have to use that. So if we don't have that, what could I use to decide? Yes. Yeah, test point. Normally 0, 0 is a pretty easy one to try. Is the origin a solution to that inequality? Yes, and that's why I would be shading this side of it. I just put little arrows over there to indicate that side. Now, if 0, 0 were not a solution, I would be shading the other side. Do you know what shape this region is called? Half plane. Well, the half plane, which makes perfect sense, doesn't it? Is it? Right, it's kind of weird. It's just called a half plane. That doesn't mean like measure it. Yeah, they're both in. Okay, so the other one, I'll just subtract x from both sides. Just kidding. I know the x-intercept is 3 and the y-intercept is 3. Done. So I'll have this 3. I have that point right there. I have a point right about here. And now this line is going to be solid as a rock. There we go. And I'm going to shade
The right.
the right side, the upside, the side that doesn't include the origin.
Again. Wait, where?
So I just graphed the line x plus y equals 3. And since it's an inequality, I have to shade one of the sides. Now the solution, who's done problems like this before? I don't think everyone has, but okay, so this rings a bell for some of you. If it doesn't, hopefully you've at least done the shading of one side before. If not, welcome to linear inequalities. That's what we do. So you could either take a pencil and shade it or take like a colored pencil and shade it. What we're looking for, since there's two of them, we're looking for what's double coats. Do you see where that region is? It is, it's upper, right? So this is, I'll just shade that in.
Can we kind of
No.
reshape?
Yes, loosely shade is fine. As long as it is clear that I know what you're doing. Like if you do this, there's a little bit of a problem there, isn't there? This is not getting the entire. And a lot of people do this, they imagine this other boundary. I just need to see that you're filling the entire place. But loose is fine. Just make sure it's clear that you're getting the entire one and not getting some arbitrary boundary. But yeah, it's fine. Thank you for asking. And if you want to do something like this is not a bad idea, just to kind of put those in. As long as they're not vertical or horizontal, because that could just blend in with the axes. That would do it too. So how many points are solutions to this system of inequalities? Infinitely many, and they all exist in that region. Any questions? Perhaps your question is, can we try another? Is that your question? No, maybe your question is, can we get to the packet, please, Mr. Lieberman? In which case the answer is yes. Yes, we can. That was your second question, I know. Sage, you know me so well. It is crazy. Oh, look at that. I'd like you to discuss what this looks like, what this graph looks like before you put anything on paper. Nice one, buddy.
Yeah.
Is negative.
And then you trade.
To the left, and then left. Once we talk about it, figure out.
Okay.
Can you show what the parent function looks like just on the whiteboard in front of you? Just trace over here, please. The parent function should look like this, right? Just 3 to the x. And this negative in front, can you show me what that's going to do?
No, I know.
Reflect it over the y-axis. And this -4 is going to move it. Please, commit, like, show me which direction, and then so you could compare with one another. Which direction are we going? I'm seeing all different directions except for up. That's interesting. Okay, I'll put up. Which way is it?
That's that.
How do we know it's left? Factor out the negative. Right now it says negative x minus 4. We want to know what's happening to the x. So factor that out. X plus 4, so it is 4 to the left. And how many points are you graphing to make this happen? Great.
And then we would shade as previous shade.
Nice. And a plot, please. So these are my first three. I think that's where they go. Does that, are those exact same 3 points that you need? This is the original, so this is, did I do that correctly? I reflected each one over the y-axis and moved it over. Over 4. Should I move the asymptote? Yeah, it's important to shift it to the left, isn't it? The horizontal asymptote. Don't forget to shift it to the left. Okay, there we go. Oh, I messed up, didn't I? I'm completely messed up. Yeah, it's got to be dashed. The function's right, but
Use a race section.
absolutely, it's difficult for me to do that digitally, but you're welcome to do that as long as it's clear that you've erased some. Doesn't have to be perfect. Am I done? Actually, I haven't graphed anything yet. I have to choose a side. Does the origin work? Check the origin. 0 is greater than anything positive. I think that's wrong. Okay, so we're going to shade the other side. And I'm going to go ahead and use a highlighter here because I can.
Fail.
I went so over the line. I was hoping you would see that, Baron. Okay, it's not perfect, but that's the idea. And that region is called? I'm not actually sure. Maybe a half plane. I'm not sure. I know that one side of a line is called a half plane. I think there's arguments that that is half of a plane. It just seems imbalanced. Yes.
Like, obviously it keeps going on, we just draw an arrow, you know.
Oh,
approaching.
so like, oh,
It's okay if, we only, do we need to do our scribbles beyond there? Can we just do our scribbles until the arrow?
maybe something like this. Something like this. It's fine. As long as it's perfectly clear to me that you know what's going on. If you just want to do little indicators like that. Notice I did go over that x-axis or the y-axis to indicate there's something on the other side. Yes.
So is any line a half plane or is it just?
Any line divides a plane into 2 half planes, but I don't know about any curve. I'm just not sure. And I don't think it's anything you should care about. I'm not going to like test you on that vocabulary. Just for information's sake.
You
can Baron.
One of the.
Uh-huh.
The arrows. Solution or do we-
You're fine to be just in the solution. So you're welcome to kind of leave the shading in your head until that end, because especially when you have more than 2 lines, it gets a little crazy. Yeah. I think we can go to this one. Let's do it. It was 23 minutes long, so I'm gonna take the last
23.
36 and a half minutes. What's that? 23.
Who decided on that?
Oh, 20, they were complaining. It's it was supposed to be interesting.
I support it.
But we're like the company.
If you're the first one, Dave. I've never given that. This pass will probably need about 14 minutes, considering you're into line.
Oh,
yeah.
Yeah. I'm telling that study.
If you're a rock, we're doing 20.
Okay. If you're solving for y, I have to ask you why. No, but seriously, try the other method. I think it's really nice. Until it isn't.
All it's on. That would be inappropriate.
And solve it.
That's-
Just so you
On the.
If anyone from block 7 is listening out, I was just kidding.
You just like outed yourself because now we know what. Oh,
What's that? I only have two we got
you
this.
didn't know that.
Yeah. Just digging deeper, huh? Just digging deeper. Pardon? But read the other read.
Yeah.
Oh, I can't use this.
Uh,
Like the other means.
Say it's her birthday.
Did it? It was like. Did it?
Not this. I believe today is your unbirthday.
So are you looking for second?
Did you get it? Check with the neighbor, make sure they're not completely confused.
There's no works.
Don't find the interest in,
Every line will stay.
I just like to.
Yeah, but if you're a little too late to that one.
So, yeah.
Oh, or you can like.
That's a good idea, though. I like that. Change the scale.
You did everything.
No, it feels like a Friday. The next week is
Is that?
like, I'm.
Are you done yet?
Lens are a bit squiggly. It gets there.
No.
I'm trying to make my music.
Sorry for that. I was gonna go to I should take some.
Okay, so the first one. X-intercept. 5. 1, 2, 3, 4, 5. Okay, y-intercept. Did you divide everything by 60? Just like simplify it? You can, or you don't have to. I think it's simple enough to do it as it is. Looking at the second one, I see the x-intercept is. The second one, x-intercept is 3. Yeah. Oh, I should draw this solid line, shouldn't I? And I should analyze which side we're graphing because it says
Away from me.
okay, 0 is not greater than 300, so I'll just put a little line here to indicate which side it's on. So the other one, x-intercept is 3, if I understand correctly, and the y-intercept is going off the grid.
You're gonna go way more out.
Really?
Yeah. You're gonna
So
go-
this is just a foretelling. Okay. 4 off the grid?
Just make the grid bigger.
Okay, yeah.
Supposed to do.
Or change that from a 90 to like a 60 or something. Pardon? I must be excited to get to math class. So now,
It'll be very late.
Yeah.
so 0, 0, not a solution. So we're going to do this side. So far we have the region that could be described as the upper right. Yes. Okay. What's the slope of the last time that we did?
2. Yeah.
-2.
-2.
We got to the slope from here.
I don't know why.
The 2x. The 2x.
Let's see, the slope, this one is -1, so.
Oh,
Good thing.
is it the X coefficient over the Y coefficient?
You take the x coefficient or y coefficient and negate it, flip the sign. Yeah. And here the slope is -1, here the slope is -2. So here, because we get off the x-intercept, we could at least do the y-intercept. The y-intercept is 3. I'm just gonna say that, I know the slope is
-1/3.
-1/3. Another little tidbit, which I think gets you there, doesn't it? It gets you the same place. So we have this line. And once again, we're shading above. So I want the triple coat,
Okay.
which is upper right still. I'll do the there we go. Yeah. Okay. Moving right along. Let's try this one. This is kind of fun. Let's see what you can do.
Oh.
Yes.
Yeah.
Case H, the one you've been waiting for has arrived.
I've been waiting for this one.
You didn't even know.
Yeah. Yeah.
Oh, it's a parabola.
Oh,
You're-
yeah, it doesn't equal. Right, when you graph it, it's the first. Negative this.
No, but then you only get. So-
Bigger.
Yeah.
X equals y squared. Yeah.
Yeah. That.
Oh, exactly.
Did you get it? I'm gonna call on someone. I just want to know some thoughts. It's been too much of me today.
Like a.
Sure. Yes.
Super inappropriate. What negative two?
Take some time to discuss with your neighbor. I'm gonna call on someone. Destiny has already chosen a name.
If it is me, that would be pretty fun.
Why would that be funny?
Because you said this is the one I'd be.
Oh, that would be funny.
It's me. I know it's me. All right, Derek, we gotta get this right.
0 minus 0. X plus positive 2 intersect.
And the part that gets shaded.
Okay, so ready or not, I'd like to hear what you're doing. Ronan, can you help me out with this one, please? I like that. Okay, so let's give Ronan a moment. Or listen, yes? How do I do this?
I just got them both into like equal equations, so the first one is adding loss to both sides.
Okay, what is happening here? So you said that y is greater than, as x is greater than y squared? Okay. We subtracted 2 from both sides. So x minus y minus 2. Oh, okay. Okay. And what are we gonna do with that? X is greater than y squared.
Right, that's pointed in.
Are we good with that? Sideways parabola opening to the right with origin at 0, 0. Shall I use my 1, 3, 5 pattern? Yes, except this time it's counting x's instead of y's. So we have these 1, 3. I think that's all that's left. And of course, it's not going to be solid. Okay. Now how do we shade though? We haven't done anything like this. What did you do? Pardon?
Yeah.
Okay, listen up. So you plugged in this point?
Yeah.
Okay. And so you plug in 0, 1.
I got a true statement. So it's not in there, so it's like anything in the parabola.
Does that make sense? There are two regions, inside the parabola, outside the parabola. He chose one outside the parabola, didn't work, so the region we shade is inside. Fantastic. Thank you. So I'll mark it kind of like this to indicate it's the inside. What's that? Yeah, it's the whole parabola. It's x equals y squared is that entire parabola. Now, I know some people, again, many of you are addicted to solving for y, so maybe you did something like y squared is less than x, and then you took the square root and you said something like y is less than plus or minus square root of x. This is where you get into iffy territory. I can't do that now with inequalities.
Well, you can.
Not square roots. Well, because then what does this mean? We have x is less than square root of x and x is less than negative square root of x. Is that what it is? We do have the positive square root of x, we have the negative square root of x. But this is saying y is less than that, so we're gonna like shade down here.
No, because it's the negative, and then you can flip it, and it's like. That's.
Okay, yeah, you could adjust it. You could adjust it. Yeah, if you're being thoughtful about it. Just don't do anything mindless. Let's just keep it, in my opinion, let's keep it in here. Recognize this is sideways space, opening parabola, and then just check. And since y is greater than x minus 2, I guess what you did is use slope intercept form. So -2, we have that slope of 1. And this one is also dashed. And what is it, above? So you see what region? A little piece in there. Ronan, thank you for your help. Any questions? What's that region called? The bounded region. It's not called a half plane, that's for sure. You could say the region bounded by the two inequalities. Let's do one more. This seems like fun.
It's a donut.
The circle B.
So, you got some shading and the frosting and not the actual hole.
Wow. No, it's not a bagel.
It's a donut. It's a donut.
It's a bagel.
Bagel. It's a donut. It's a donut. Because bagels aren't like.
No, but it's kind of like that on the bottom.
They recognize that the first inequality is the shape of a
Circle
circle radius 3, and we're gonna shade.
insert.
I know it's the inside.
Less than.
Like 0, 0 satisfied, or 1, 1, or anything inside. To try 3, 3, that'd be outside of it.
You can't cheat.
So it's for the origin bit, so it's be a circle. And then the other one is another circle, radius 1, and here we're shading outside, so we're left with a donut. Yeah,
Oh, yeah.
like a
It's
pumpkin
not what it
bagel though.
was.
And you see, you could use the intercept.
It's a chocolate donut.
X-intercept.
This chocolate donut.
Y
It is a chocolate
So
donut.
it'll never be.
Loki is on a bagel.
It'll circle. And everything else.
Chocolate is not
Traditional.
Fries, yeah.
It's a board.
They're not as good.
You know, circle on that. Oh, like a target? Yeah. That's your work. Right, it's not a double
What
code.
are we doing?
No, it's only and. Systems is like this inequality and this inequality. But that's an interesting extension. Maybe next year I'll share my kids. I'll call it the Barron problem. Maybe I'll wait till after you graduate. Okay, and
Okay.
I think that's enough. I think any more would just be like,
Yeah.
it's good. I think, and maybe that was already overkill. So you have a couple minutes to zone out and get switch back into exponential mode. As we are done with this one, just one more lesson. We'll need a calculator.